In this lesson, we're going to learn how to work with exponents in expressions that involve multiplication. To develop an understanding how multiplication works, we can write things out and look at the extended product. X to the third is x times x times x. X to the fifth is x times x times x times x times x. Since exponents represent repeated multiplication, and we see here that we have x being multiplied together a total of 8 times, we can write this expression as x to the 8th power. The extended product makes that simple. We can simply write things out and count up the x's, but it's really not necessary to do that. The exponents tell us exactly how many x's there are. The first term, x to the third, tells us we have 3 x's. The second term, x to the fifth, tells us we have 5 x's. If we take those exponents, 3 and 5, and add them together, we find x to the 8th power, which is exactly what we found by writing out the extended product. When dealing with multiplication, we have a general rule. X to the a times x to the b equals x to the a plus b. In other words, when multiplying like bases, add their exponents. Throughout this video, we'll look at a variety of problems to help you build your understanding of using multiplication when exponents are involved. In our first exercise, we want to multiply y to the third times y to the 8th. We could write out the extended product, but it's not necessary. We have like bases here, both are y's, so we can add their exponents together, 3 plus 8. The product is y to the 11th, and we're all done. Here's an example for you to try. Multiply x to the 12th times x to the 4th. Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We have like bases of x, so we can add the exponents 12 and 4 together. 12 and 4 is 16, so the answer to the product x to the 12th times x to the 4th is x to the 16th. In our next exercise, we'll add a coefficient. We want to multiply 6a to the 4th times 2a to the 3rd. When multiplying, we begin by looking at the coefficients 6 and 2, which we will multiply together. We then look at the variable a, which is the base. We have a to the 4th and a to the 3rd. Since we have the same base, we add the exponents together, 4 plus 3. So we have 6 times 2, which is 12, and a to the 4 plus 3, which is 7, 12a to the 7th. Here's an example for you to try. Can you find this product? Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We begin by looking at the two coefficients, 9 and 2, which we need to multiply together. Then we see we have like bases of x, so we can add those exponents. X to the 3 plus 5. 9 times 2 is 18. 3 plus 5 is 8, so x to the 8th. The answer is 18x to the 8th power, and you're all done. In our next exercise, we're going to see exponents that are actually a little bit different. They're binomials. We want to multiply x to the 2a plus 5 power and x to the 5a plus 3. We see two bases that are identical, both are x, so we're going to add the exponents. We'll take x to the 2a plus 5, and we'll add the 5a plus 3. Now we combine the like terms. We have 2a plus 5a, which is 7a, 5 plus 3, which is 8, x to the 7a plus 8. Here's an example for you to try. Can you find this product? Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We notice we have like bases, both being x, so we can add the exponents together. 5a minus 4 and 6a plus 10. To add those exponents, we combine the like terms. We have 5a and 6a, which is 11a, and negative 4 plus 10, which is positive 6. So x to the 11a plus 6 power. In our next exercise, we see something a little bit interesting. X to the third times x to the 0 power. We've not seen an exponent of 0 before, so let's see how that works out here. We want to multiply x to the third times x to the 0, and we see we have like bases, so we know we can add the exponents together, 3 plus 0. 3 plus 0 is 3, and so that's the answer. It's interesting that when we multiplied x to the third times x to the 0, we got x to the third back. We typically only see that kind of behavior when we multiply by the number 1, which brings us to another rule that's worth knowing. Anything to the 0 power is equivalent to 1. When we multiplied x to the third times x to the 0, it was the same as multiplying x to the third by 1, giving us x to the third as our answer. Here's a problem for you to try. In the next exercise, we see an interesting phenomena, a negative exponent. Although we'll talk about these negative exponents in much more detail in a separate video, for our purposes here, the process is exactly the same. We begin by multiplying the coefficients 3 times 8, and then we identify the like bases, which are the x's. We add their exponents, 7 plus negative 4. 3 times 8 is 24, and x has an exponent of 7 plus negative 4, which is 3. 24x to the third. Here's an example for you to try. Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We begin by identifying the coefficients, 9 and 6, which we will multiply together. Then we identify the like bases, x, which have exponents of 12 and negative 4. We'll add those together. 9 times 6 is 54. 12 plus negative 4 gives us the exponent of 8 on the base of x, 54x to the 8th. In our final problems today, we're going to look at examples that have two variables. Here we have x to the 7th and y to the 10th times x to the 5th and y to the negative 3. We have two separate bases here. First, we have the x's. We'll take the x's and add their exponents together, 7 and 5. Then we have a second base, which is y. We'll take the y and add those exponents together, 10 plus negative 3. Now we simply have to do the addition. For the x, we have 7 plus 5, which is 12. For the y, we have 10 plus negative 3, which is 7. X to the 12th, y to the 7. Here's one for you to try. Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We have two separate bases, x's and y's. We take the x's and add those exponents together, 9 and negative 3. We then take the y's and add those exponents together, 5 plus 7. We perform the addition, x to the 6th and y to the 12th, and that's our final answer. This is everything you need to know to get started working with exponents in expressions that involve multiplication. You can learn more about exponents in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.